Okay, so good day, class. So now let's have the water distribution system for our plumbing. Okay, so there are sources of water. So first, for domestic use, you have the rainwater, and then how to collect it. So you have the collection, and then the advantages of rainwater, and also the disadvantages. So you have here. So for the collection collected from roof or buildings and special watersheds and stores in cistern tank or ponds. Cistern water for drinking should be boiled, chlorinated, or otherwise sterilized. So sometimes rainwater are also uh, used for drinking in some other places with no line of potable water. And then advantages, you have the water is soft and pure and is suitable for the hot water supply system. Sometimes from the collection, you have the cistern tank. You pump it through the gravity tanks and then you distribute it on the building that is by gravity. And then only a source during the wet season. So for the disadvantage of this rainwater, so only during a rainy season, so you have the rainwater collection. Then storage become a breeding place for mosquitoes also. Then roof may not be clean sometimes for water consumption, for human consumption. Maybe the roof is not clean, so that's the disadvantage if you drink water from the rain. Then another, you have the natural surface water. For the collection, you have obtained from pond, lakes, and rivers through reservoir and through the penstocks. Then easy to acquire, usually in large quantities. You have this disadvantage, the advantages. And then used for irrigation industrial purposes and when treated for community water supply. And then for the disadvantage, it contains a large amount of bacteria and organic and inorganic substances. Purification and treatment is necessary for natural surface water. And then you have for the groundwater, so obtained from the underground by means of mechanical or manual equipment. So you have the pump and also the puso and maybe the well. So you can have the groundwater. For the advantages, you have usually has an abundant supply. So, but there are areas that maybe there are less water, less groundwater. And then it requires less treatment because of natural filtering, since that is from the surface water and then it goes down to the soil, and then maybe that's natural filtering through the soil. So that is for the groundwater. And then for the disadvantages, so we have organic matter and chemical elements. Treatment is subjected. So normally, for all the water, sources of water for domestic use, it should be treated. Okay, so maybe for the next slide, we will discuss the natural purification processes and the treatment method. Okay, so those are the water sources. So rainwater, and then natural surface water, and then the groundwater. Okay, so in water treatment, so you have there the problems, the causes, the effects, and the correction for the water treatment. So you go through with this. You have this copy already in your Moodle. So you go through with the water treatment problems and then the causes. You have the acidity of water, the hardness, then turbidity, and then the color, and also for the pollution. These are the water quality problems and their correction. You can have the problems and how you can correct the problems for that particular problem for quality of water. Okay. And then objectionable element and reasons for treatment. So this is treatment and purification. So for calcium, so more this is to be discussed, and maybe you have your environmental engineering, maybe it will be discussed further there, since for this slide, maybe it only summarizes all the elements of water treatment and purification. Okay. So you just go through with these slides. So how to treat the objectionable elements using these methods. Okay. Example, you have for carbon dioxide and hydrogen sulfide, you have for that is aeration or method of treatment. And suspended materials, you have coagulation and settling process. For bacteria, you have chemicals and filtration. Calcium and magnesium, you have addition of water softeners. For iron, you have iron filters. Then sulfur is chlorination, method of chlorination. Then for pathogenic germs, you have disinfection. And for acid, you can have limestone filtration or marble filtration. Okay. So for the purification of water, so for aeration, that is the spraying of water into the atmosphere through jets or passing it over through a surface to remove entrained noxious gases such as carbon dioxide and hydrogen sulfide. So this is the process of aeration. One. So for coagulation and precipitation, so addition of coagulants such as ferrous sulfate and lime to the water, which cause the larger suspended particles to form a gelatinous mass which precipitates readily. The precipitate is gathered in large dams and disposed of. Okay. That is the process. And then for filtration, water is passes through layers of sand and gravel in concrete basins in order to remove the finer suspended particles. Okay. You have there the illustration. So from here, you pour the water, then you have the sand and gravel, and after that, so this is the water outlet. Maybe for the purification of water, so this is by filtration using sand and gravel. But maybe they maybe use another material, like for example, you have marbles and then sand, gravel, then you have charcoal. So it depends on the filtration process. Okay. Next is sedimentation. Water is passed through basins so sediments can settle through a period of time. So like in catch basin and septic tanks. So for example, septic tanks, you have the wastewater. Then after that, you have another chamber. So you have a period of time to settle all the solid particles or sediments in this chamber. And then next you have another chamber to settle all the sediments or the solid particles. Then another chamber until the water that goes through this last chamber may be purified, or maybe not so, or maybe clean water. Okay. Next is chlorination. So water is injected with hypochlorite or chlorine gas to kill the harmful bacteria. So this is the main process, or the most common process of purification of water. So water coming from the MCWD, or you have the municipal water lines. So maybe their tanks is filled with chlorine. So that's why you have the color white water sometimes in your pipelines. So that is a chlorination process. So let's have wells and pumps. Okay, so there are type of wells. General, you have shallow and deep. For individual wells, so you individual well spring. So there are type according to method of construction. You have dug. So for dug well, this is the most common type, and usually dug manually or excavate manually. Then that is around 15 meters depth, but it depends if there are water, or the natural, or the water table is maybe lower than 15 or greater than 15-meter depth. So maybe for this 15-meter depth, it depends on the water table. And another term for dug well is shallow well. Next, we have the bored well. So for the bored well, this is bored, no, meaning excavation or by the use of mechanical means, similar to dug well, but constructed using an auger driven by hand or with power tools. So sometimes that is using mechanical tools, like in as the construction of the tunnel in Mambaling, you have the board piling. So they board or they excavate the area using mechanical auger. No? Then seldom hand-driven below 15 meters, but can reach 40 plus meters with power tools. Okay. Next is jetted well. No? So use of extreme water pressure so as not to affect existing foundation in the vicinity. So by the way, when you have the well construction, it depends on the area. So you cannot directly use jetted well or bored well if the area is too busy or the vicinity is too close to any foundation of the building. So it depends on the construction method. Okay. So also it makes use of a suction pump above while casing acts as the pump riser. So since it uses water, so therefore you have to use a pump for the excess water. Then use only where ground is relatively soft, hence sometimes referred to as sand point wells. It depends also on the area and the condition of the vicinity. Next, you have driven. So dug with a sharp pointed hollow slotted iron rod and well screen. Depths are from 10 meters to 15 meters. So driven meaning you have to drive an iron rod. So maybe you can see that in bridge construction, you have driven piles. So that is the same method with the driven well. Then you have drilled well. So you have there the illustration of the drilled well. Okay. So used for drilling oils and can reach up to 1,000 meters or 1 kilometer. Okay, so locating a well. So two most common sources of contamination, septic tank and or leach fields, sump pit, or you have the privy, livestock feedlots. Then location of wells must not be less than 100 feet away from such pollution source. So also based on the certification in the plumbing plants, in every plumbing plants there should be a certification stated that no no wells or pump for 25-meter radius from the septic tank. No wells or any type of pumps must be located 25-meter in radius from the septic tank or any pollution sources. We have septic tank, leach fields, livestock, and livestock feedlots. Okay. And locate on higher grounds. You should locate that on higher grounds for the wells. The deeper the well, the better for natural filtration. Since the standard wells should be at least 15 meters in depth. Okay. So methods of well screening. So these are the methods. Maybe you can also search in the YouTube or internet some on how to construct deep wells or shallow wells. For this well screening, well screens are made of non-corrosive materials like brass. Okay. Natural material like stones and rock sediments provide additional screening. So there are many types of methods in well construction. No? You can search that on the internet. Maybe we can have activity on that. Okay. Next, we have two basic types of pumps. First is the piston pump. It is where water is sucked into a sealed vacuum by the use of piston, and is single action. Water is drawn in with one motion, or double action. Water is drawn in either strokes. Okay, these are the diagram for the piston pump. You have duplex or twin piston pump. Okay, so piston pumps are water pumps using piston. Okay. Next, you have centrifugal pumps. Water is drawn into the pump and discharged with a centrifugal force. Okay. This is the illustration of the inside of the pump. Okay. So maybe also they use the from bigger pipes to smaller pipes so that the pressure of the pipe becomes bigger also. The types and classification of pumps. You have reciprocating pumps, the piston pump that operates with control speed. The discharge from reciprocating pump is pulsating and changes only when the speed of the pump is changed. Sometimes an air chamber is introduced to regulate the pulsation. This is the reciprocating pump. So maybe the mechanical engineers can explain further for this type of pump since it uses a piston. Okay. Next is jet pumps. Our centrifugal pumps typically used for drawing water up from well. So there are 4 types of jet pumps. You have deep well jet pumps, shallow well jet pumps, and then convertible jet pumps and miniature jet pumps. So for deep well jet pumps, this is used for high volume application. So maybe you have a big area of commercial building. Then shallow well jet pumps are used for residential buildings or residential dwellings. And then convertible jet pumps can be used for deep wells and shallow wells. And miniature jet pumps are used for small application. Okay, so this is the type of jet pumps. Next, we have rotary pumps. Are piston pumps that make use of a pump driver and can just discharge from 900 to 1,200 GPM, okay, per minute, gallons per minute. GPM. Also are more efficient for viscous fluids. And then next we have submersible pumps. So you have submersible pumps are designed to be fully submerged within a tank or other media storage receptacle. From the word itself, submerged, so it should be submerged fully. Since if that pump is not submerged fully or maybe half submerged, maybe that pump can be destroyed. So many common types of pumps can be designed by manufacturer to be submersible. It depends also. Maybe you can use jet pumps and submersible, and it is submersible. Next is sump pumps. Sump pumps are used in application where excess water must be pumped away from a particular area. Also, in general, it is a category that encompasses a number of styles of pumps that are used to pump out collected fuel. Okay? So you can use this in jetted wells. No? You can use some pumps in jetted wells since you have excess water during the construction of that wells. Next is turbine pumps. Are centrifugal pumps used for large application because of their multiple impellers. Turbine pumps can discharge up to 2,000 GPM, gallons per minute. This is turbine pump. Next, we have water tanks and cistern tank. The type of tanks for domestic use, you have overhead tank. So that is the tank in your, maybe in your roof or another structure, but above your roof. Does not have any pressure concern, but relies on gravity to supply water to fixtures below. And then usually made of galvanized steel, stainless steel, or reinforced concrete. It can come in various shapes and sizes. So maybe you can see this mostly in hardwares. You have ready-made overhead tanks. Next is cistern, usually built of reinforced concrete, underground, and connected with a pump. Okay. Next is pressure tank and hot water tank. These are the type of tanks for domestic use. The gravity supply tank, it is used in overhead feed system. The main components, you have this type of tank. So this is the diagram. You just go through with this diagram since you have already the slides. Supply pipe, inlet, overflow pipe, drip pan, and the gate valves. This is for the pneumatic water tank. And then let's have the types of hot water tank. So first is range boiler. A small hot water tank 30 to 60 centimeter in diameter and 180 centimeter maximum length. Made of galvanized steel sheets, copper or stainless steel, and standard working pressure limit is 80 to 150 pounds per square inch. Another is the storage boiler. So large hot water tank, 60 to 130 cm in diameter and 5 meter maximum length. So normally for residential building, we just use a range boiler. But in some cases, for residential buildings that is too big, no? Maybe a 3-story residential building or more, you can use storage tank heater or boiler, storage boiler. But for 2-story residential building or maybe commercial building, you can just use range boiler. For storage boiler, it is made of heavy-duty material sheets applied with rust-proof paints. And standard working pressure limit is 60 to 100 psi. Next, we have the control valves. So control valves, you have its function, control the water system, start or shut down a system, regulate pressure, check the backflow, control the direction of water. So those are the function of the valves. Since there are, I think, 6 types of valves. And then the rules regarding location of valves. You have this. Locate and distribute valves in such a manner that they can isolate a certain section of a network in case of a system breakdown before its branches. So before you can branch out your main line of main water line, you can have a valve or maybe I think a glue valve or a gate valve. Okay, and then in one toilet and bathroom, you should have at least one check valve. Okay. Also, locate valves where they are not too visible while remaining accessible to users. Okay. So this is the diagram. So before you can branch out, you should have a valve here, and then if you need to have another branch, so you have to put another valve. Okay, sometimes this is a gate valve. So the type of valves, you have gate valve or what we call full-way valve. This is used mainly to completely close or completely open the water line and does not control the flow of water. Also, this is used in our water meter area. You can have the gate valve. Best suited to the main supply and pump lines wherein operation is infrequent. Okay, so there are 2 types of gate valve, the wedge shape or tapered desk and the double desk valve. Next, we have the glow valve. It controls the flow of water with a movable spindle. Can reduce water pressure, throttling, and only one side of the valve is an inlet. So maybe for this type of valve, the faucet, for example, the faucet, so this the faucet uses the mechanism of the glow valve. There are 3 types of glow valve. You have the plug type disc, and then you have the conventional disc valve and the composition disc valve. Okay. Next, you have the check valve. So the main function is to prevent the reversal of the flow or backflow in the line. So this is commonly used in toilet and bathroom, since sometimes the water tank or the flush tank of your water closet can have the backflow or the reversal of flow of water in it. So you will put the check valve in between so that the water coming from or from the flush tank will not go back or will not backflow to another fixtures. There are 4 types of check valve. You have the swing check valve, the lift check, vertical check, and the horizontal check. Next, you have the angle valve. Operates in the same manner as glow valve, disc, and seat design. Used to make a 90-degree turn in the line and reduces number of joints. Another, you have the foot valve. Locate at the lower end of the pump. Used mainly to prevent loss of priming of the pump. Or the other term for the foot valve is the retention valve. Then you have the safety valve. I think this is the last type of valves. So used on water system, heating system, compressed air lines, and other pipelines with excessive pressure. Okay, so this is the safety valve. Next, we have the type of faucets and bib or bib. Faucets, bib, and spigot are just the same meaning, okay, in plumbing. You have the compression cup. So operates by the compression of a soft packing upon a metal sheet. This is the illustration or the diagram. Compression pump, a compression cup. Next, we have key cup. Operates with a round tapering plug ground to fit a metal sheet, whose bib has grooves fit for the hose. Okay, so this one. And then you have the ball faucet, constructed with a ball connected to the handle. Okay. So these are the defects in water distribution system. First is water hammering. So sometimes you can experience this once your pipelines vibrates. That is water hammering. So a knocking in the pipes caused when the faucet in the lower level are shut off abruptly or automatically. The force exerted by the decelerating water causes the pipes to shake and rattle. Okay, next is back siphonage. The flowing back of used, contaminated, or polluted water from a plumbing fixture or vessel into a water supply pipe due to a negative pressure such as pipe. Or how can you prevent it? For back siphonage, you can install the check valve. For water hammering, you can install the, for example, you have this this faucet. You have here, you install T fittings. Okay, you install a T fittings and then you extend a pipe here. You extend a pipe and then cover it with cap or a plug. So the water hammering can be eliminated. Next is backflow, the flow of water or other fluids mixture or substances into the distributing pipe of potable supply of water to a tank, plumbing fixture or other devices, and the flood level rim of the receptacle. So the flood level rim of the some receptacle, you have, for example, you have in the lavatory, you can see a hole in maybe a hole maybe at the top. So that is the flood level rim. So once the water reaches that hole, automatically the water goes through that hole and go back. That's backflow. Another is expansion and contraction. Pipes expand and contract due to continuous changes in temperature. An airspace should be provided to allow for breathing room. Okay. Next is friction head loss. Friction occurs when liquid flowing through the pipe. The pipe makes contact with the pipe enclosure, thus reducing the speed of water flow. And there is a greater friction head loss with longer pipes, small diameter pipes, and higher number of valves of fitting. So to minimize it, you can have at least 20-meter pipes connected with coupling, and then you change the direction so that you can limit the length of the pipeline. Next, we have classification of public water distribution. So direct pressure distribution of this illustration. So water is obtained through a large intake installed on a lake basin and extended into deep water. Components, you have water basin, receiving well, and then filtration plant. Next, we have the indirect waste distribution. Water is taken from a drilled well or underground water and involves individual special mechanical equipment. Next, we have the parts of the cold water distribution system, potable water and tap water. First, you have the service pipe. This pipe from the street water main or other source of water supply to the building served. Next is the water heater, a water meter, device used to measure in liters or gallons the amount of water that passes through the water service. You already know what it is. And then the horizontal supply main. So the principal water distribution pipe running from the water meter from which the various branches and risers to the fixture are taken. So you have the horizontal main pipe. You have from the water meter, that's the that lies horizontally from the water meter to your building. That is the horizontal supply main. Next, we have the riser. So water supply pipe extending vertically one full story or more to convey water into pipe branches or fixture. So you have that pipe stand vertically from ground floor to second floor connection. Next is fixture branch. The water supply pipe between the fixture supply pipe and the water distributing pipe. So from the horizontal supply main pipe, so connected to that is the fixture branch. Next, you have controls and valves used for control, isolation, and repair of the water distribution system. Next is storage tanks. Types of cold water distribution system within buildings. You have here the upfeed. You have from or direct upfeed. Water is provided by the city water companies, or you can have the MCWD using normal pressure from the public water main. You have here the water distribution from municipalities or other companies provided. Then you have the corporation staff, you have your pipe, and then going to your building. That is direct upfeed. Air pressure system or pneumatic. This is using pump. You have the storage tank and then you pump it to your second floor and to other floors. No? That is up feed. If you don't have an overhead tank, so you can have the up feed system. So when pressure supplied by the city water is not strong enough, maybe some areas the water is not, or the water supply is not strong enough to have your second floor enough water, or maybe your third floor. Okay? So that's why if you have a 3-story building, so you should at least have a overhead tank. Okay? Compressed air is used to raise and push water into the system. Next, we have the downfeed. So you have the overhead or the gravity system. So water is pumped into a large tank on the top of the building and is distributed to the fixture by means of gravity. So also, you need the pump to pump the water to your overhead tank. And then you distribute it by gravity. This, there are also advantages and disadvantages of upfeed system and downfeed system. You'll just go through with this slides. Next, we have hot water distribution. So in buildings, you have upfeed and gravity return system. So with a continuing network of pipes to provide constant circulation of water. So also you need a pump in this type of system. Hot water rises on its own and does not need any pumps for circulation, but it depends on the pressure. Next, hot water is immediately drawn from hot water is immediately drawn from the fixture anytime, provided economical circulating return of unused hot water. Larger pipe is installed at the top of the riser, and the diminishing pipe passes through the lower floors of the building. Then you have the downfeed and gravity return system. So maybe for cold water and hot water, you have the same system used, downfeed and upfeed. Okay. Also, you have here the pump circuit. So for a more efficient circulation of hot water to the upper floor level of multi-story building. So this is used for a multi-story building, maybe for 4-story and above. For 3-story, you can just use either upfeed and downfeed distribution. Hot water consumption. So you have here the kind of buildings and gallons per person per hour. So you can compute now your the capacity of tank to be used in that particular building because of the occupants. Okay, so maybe we'll have an activity on that, on how to compute the volume of tank to be used in that particular building. Okay, we'll just go through with this slide. And then you have the 2 types of water heating system: hot water space system and the hot water supply system. Okay. And protection of hot water tank, you have system relief valve used for hot water space heating system. And then you have temperature and pressure relief used for hot water supply system. Next, we have hangers and support. Since all pipes should be hangered, I think at least it depends, by the way, in using pipe materials. For example, if you use PVC pipe, you can at least have a hanger or support in between 3 meters or 2 to 3 meters. And then I think for cast iron, you have 1.5 meter distance between support or hangers. Supporting cast iron pipe, support shall be placed at every joint of horizontal runs unless distance between joint is less than 4 feet or 1.2 meters. Use strap iron or special pipe hangers for this purpose. So you have this type. So the most common pipe hanger is by the use of flat bars. Okay, this one. So for strap irons, this is not used as of today. The commonly used hangers is the flat bar. This one. So vertical runs of cast iron pipes can be attached to the building structure with wire staples, vertical pipe brackets, or pipe traps. Okay. Friction clamps should support the weight of the cast iron pipe at each floor level. But it depends on the situation in the area. So maybe if you have at least less than 3 meters height of the building, so no need to have clamps. Masonry anchors and or fasteners. So you have lug shields made from lead are commonly used to attach pipe hangers or fixed to concrete or masonry. Okay, this is how you can construct or you can have the lug shields into the concretes. And then you have the caulking anchors, provide a fastener which is permanently attached to the concrete or masonry. It is internally threaded to accept machine screws and bolts. Okay, so you have that caulking anchors. Next, you have toggle bolts are used when attaching pipes to the hollow masonry units with spring-operated wings. Okay, so you have this type of toggle bolts. Then you have plastic anchors, can be installed in smaller holes. So you have, I forgot the name, TOCs. You have that in our term TOCs, plastic anchors. Okay, so that's all for this discussion. So see you for our next discussion. Thank you.